Hi everyone, this video is on measures of dispersion. So that includes our range, which is the maximum value minus the minimum value. It includes our quartiles, which are values that divide the data into quarters. So we have quartile 1, or the lower quartile, which is a value 25% of the way through the data set. Q2 is the median, and then Q3, the upper quartile, is the value 75% of the way through the data set. We can then also calculate the interquartile range, which is quartile 3 minus quartile 1. This example here, for the data set that we've been given, we're going to find the median, lower quartile, upper quartile, interquartile range, and the range. And we're going to do this by hand for this example. So let's start with the median. So with the median, the first thing we need to check is if the data is in order from smallest to largest, and it is, which is excellent. So we then need to find the position of the median. So remember, to do this, we do the number of data points, which is 12 plus 1 divided by 2. So we are looking for the value in the 6.5 position. So if we look at the data, we will find we've got the 6.5 position is between the 6th and 7th numbers, which is between 36 and 49. Now, because it's between two numbers, what we need to do, we need to find the middle of these. So you can either do that in your head, or if you don't trust that, you can use this formula, which is add those two numbers together and divide by 2. And that will give us our median of 42.5. From there, the lower quartile range, where our median is. So our median is between these two. For the lower quartile range, we need to find the middle of the data below the median. So the data from 1 to 36, we need to find the middle of that for quartile 1. So if you look here, we'll see the middle is between 9 and 16. And then to find out our quartile 1, we do just as we did before with the median. So we'll do 9 plus 16 divided by 2, which will equal 12.5. So our quartile 1 is at 12.5. Quartile 3, same idea, but we're going to do it with all the values above the mean. So from 49 to 144. Find the middle of those values, and we'll find it's between 81 and 100. So we can do 81 plus 100 divided by 2 to find the middle of those numbers, and that is 90.5. Now we have those values, we can work out our interquartile range, which remember is quartile 3 minus quartile 1, which would be 90.5 minus 12.5, which is 78. And then our range is the maximum value minus the minimum, which will be 144 minus 1, which is 143. So that's how you work out all these values by hand. You can also do it with the calculator, which I will show you very soon. Before that, we are just going to look at some things on box plots. So remember, with box plots, we create them using a 5-number summary. Those 5 numbers are the minimum, quartile 1, median, quartile 3, and maximum. So when we draw a box plot, it looks like the one on the right. We have a scale on the bottom, there has to be a scale. Then we have the box and whisker plot. Now, the diagram on the left just tells us what each part of that box plot tells us. So the lowest point is the minimum. The lower end of the box is quartile 1. The line in the middle of the box is the median. The line where the top end of the box is quartile 3, and the number at the very end is the maximum. Now, when we have data, we can also have things called outliers, which are extreme values, and that we might consider to remove them from our data sample. To work out if there is an outlier, we do the following. So an outlier is any value 1.5 times the interquartile range above Q3 or below Q1. Now, this example here, we're going to use your GDC to find the median and upper and lower quartiles for the given data set. We're then going to draw a box plot, and then we're going to find out, is 37 an outlier? So to use your GDC to work out your upper quartiles, we'll do the following. So on your calculator, what I'd like you to do is go to your spreadsheet, as we've done previously, and we're going to enter all the data. And remember, enter it all into the same column. Once we've done that, we can calculate our statistics. So remember, we need to go Menu, number 4 for statistics, stat calculations, and then one variable. Click OK on this little box that pops up. And once again, remember, our data is in column A, so we can leave that with the A square brackets. We don't have a frequency list, so that just stays as 1, and we can have our answers in column B if we want, because there's nothing in there. Once you're happy with that you have the correct column selected, click OK, and our stats will be calculated. So we need to go down through a few of the stats, so pass the mean, pass the sum of the x values, and then we get to a point here, and we'll actually be able to see the 5 numbers here that we need to create a box plot. And now we've been asked for this part A to find the median, upper quartile and lower quartile, so really easy, we just read straight off the calculator. So our quartile 1 is 44, median's 47, and quartile 3 is 51.5. So we know that the median is 47. So median equals 47. We know that quartile 1 was 44 and quartile 3 was 51.5. Now with these numbers and our maximum minimums, we can do part B, which would be to draw the box plot. Here is one I prepared earlier, and remember, with the box plot, this value at the end here, that is your minimum, so that's 37. The value of the end of the box is the quartile 1. The line is the median. The edge of the box is quartile 3, and the number at the end is the maximum value. Now we want to determine whether 37 is an outlier. So to do this, remember, we need to work out the value that is 1.5 times the interquartile range below quartile 1. Because 37 is the smallest number, we want to work out that value below quartile 1. So the first thing we need to do is the interquartile range, which will be 51.5 minus 44, quartile 3 minus quartile 1, which we will get 7.5. Now to work out if it's an outlier, we know we need to look at quartile 1 because we're looking at the smallest value, and it's going to be minus 1.5 times the interquartile range, which will equal 44 minus 1.5 times 7.5, which gives us a value of 32.75. Now when we look at 37, we know that 32.75 is less than 37, therefore 37 is not an outlier. It has to be smaller than that number to be an outlier. Now if we were looking at a really big number, then we would be doing quartile 3 plus 1.5 times the interquartile range, and if that value was bigger than that number calculated, then that would be an outlier. Now when to keep and reject outliers, so if an outlier appears to be due to an error in data, then it should be removed. But this isn't always the case. Sometimes you could be looking at heights of people and you have a person that's just really, really, really tall. That isn't an error, that is just their height, so you would want to keep it in. So there's just some information here that you can read, a couple of examples that to show when you may remove an outlier and when you might not remove an outlier, so make sure you give that a read. So if you have any questions on anything that we've done in this video, please just send me an email and I will get back to you as soon as I can.